Hello everyone, welcome to studygan.com. So today we are going to learn how we can build a machine learning model for wine quality prediction. So to break it down for you, we are going to cover this topic in 5 different steps. So the steps are importing the dataset, then pre-processing the dataset, and after that performing the train test split, and then training the machine learning model, and after that testing the machine learning model. So let's get started. So here the step 1 is importing the dataset. So to import dataset, before importing the dataset, we have to import the Python libraries that would be required to perform tasks while building a machine learning model, that are NumPy, Pandas, Seaborn and Matplotlib. And after that we have to import our dataset. So df equal to pd.read_csv, we have used in the read_csv command of the pandas library to import our CSV file, and the wine_fraud.csv file is the dataset that we will be working on. I have taken this dataset from kaggle.com. I will upload this CSV file in the GitHub repo and also will share the link of the Kaggle dataset in the description box. After that we have to give a look at our dataset using df.head. And we can see that in our dataset there are fixed acidity, volatile acidity, citric acid and other chemical compounds that are related to the quality of the wine. And this is the quality column, that is the most crucial column in our dataset that shows if our wine quality is legit or fraud. And this type column tells us if our wine is a red wine or a white wine. So to understand how many wines in our dataset are legit while how many of them are fraudulent, we have to plot a count plot in order to understand that. And now we can see that majority of the wines in our dataset are legit while negligible amount of wines in our dataset are fraudulent. So this concludes that our dataset is highly imbalanced. We will be working on this dataset only, but if you want to balance this dataset, you can perform SMOT algorithm. I will add a link for an article that will let you know how to implement SMOT algorithm. So let's move on to the step 2. So now the step 2 is pre-processing the dataset. So now before pre-processing the dataset, we need to know more about the dataset. So what we have to do is write df.info and see that all our columns in our dataset that are chemical formulations are of the data type float64, while the columns quality and type are of the data type object. So to understand about the data, we need to find the correlation between the columns of the data. So to find the correlation of the columns, we want all the columns to be of same data type, and for that we have to convert the columns quality and type to the data type float64. And for that we have to write this line of code where we have used two functionalities, .map and .asType. So .map is used here to map the wines with the quality legit as 0 and the wine with the quality fraudulent as 1, and asType is used to convert the quality column to the data type float64. And now we can see our dataset. So here we can see that the quality is 0, which means that the quality is legit, and if the quality is 1, that means that quality is fraudulent. And similarly we have to do it for the column type. Here we have mapped the wines with the color red as 0 and the wines with the color white as 1. And now we can see our dataset, and we have to run this line of code, and then we can see our dataset. The type 0 refers to the color red and the type 1 refers to the color white here. And now the main step is to find the correlation between our columns in the dataset, and this is how our columns are correlated to each other in our dataset. And the most crucial column here is the quality of our wine. So to understand more about it, we need to find the correlation of the quality column with all the other columns in our dataset. So for that we have to write df.correlation, and in the square braces we have to write quality. that is the name of the column. And then we can see the correlation of the quality with all other columns in our dataset. And here we can see that the increase in fixed acidity can lead to an increase in the chance of the wine to be fraudulent, and while the increase in the residual sugar can lead to a decrease in the chances of a wine to be fraudulent. And we can plot this correlation using our bar plot with this line of code. Here we are going to plot the correlation between the columns with the quality column, and we are going to remove the last two columns, that are quality and the type column, and we are going to plot a bar plot for that. And now you can see a bar plot that shows the correlation of the other columns with the quality column. And here the positive value shows that there is a positive chance of a wine to be fraudulent. So let's move on to the next step, that is the train test split. So the step 3 is train test split. So in order to perform the train test split, we need to define our features and label. So features are the input to our machine learning model, while label are the output for our machine learning model. So definitely here the label is the quality of the wine, while the all other chemical formulations are the features of our machine learning model. So here x is our features and y is our label. So x equal to df dot drop quality comma x is equal to 1. That is, x is equal to all the data frame except the quality column, while y is equal to df quality, that is the quality column of the data frame. And in the next line we are going to import train test split from sklearn dot model selection. In the next line of code we will perform train test split. So here train test split, we will pass the parameters feature that are x and label that are y, and test size is equal to 0.01, which means that 10% of our data would be for testing the model, while 90% of the data would be for training the model. And x train, x test are basically features for training and features for testing. Similarly, y train and y test are label for training and label for testing. So in the next line of code we will import standard scaler from sklearn.preprocessing. So as you can see, let's give a look at our features. So we can see that different columns in our features have different ranges. For example, total sulfur dioxide has a range of 2-digit place, while the volatile acidity ranges in decimals. So in order to eliminate this disparity and brings uniformity, we perform standardization using standard scaler. So let's create an instance for standard scaler. Scaler equal to standard scaler, and then we will perform standardization using standard scaler. So here in that features for training we have performed dot fit transform. So what standard scaler do is, it basically calculates the mean and variance for all the columns in our features and then standardize our feature dataset. So now we have scaled x train and scaled x test. So let's move on to the next step, that is training the machine learning model. So the step 4 is training the machine learning model. So here we are going to import support vector classifier svc from sklearn.svm, that is support vector machines. So support vector machine is a supervised machine learning algorithm that is used to perform classification task. And here is a visual representation for support vector machine. Suppose these green data points represents the data points for legit wines, while these orange data points represents the data points for fraudulent wines. Then what support vector machine does is, it basically creates a hyperplane in order to segregate the classes so that the machine learning model can easily classify those categories. So now we have to create an instance for the support vector classifier by svc equal to svc in capital, and in round braces we have written class weight equal to balanced. So class weight equal to balanced means is basically we will give higher weightage to the minority class, which means that we will give high weightage to the data points of fraudulent wines here, because we have seen that there were very few data points for fraudulent wines. So we will give high weightage to the fraudulent wine data points in comparison to the legit wine data points. And then we are going to import grid search CV, that is grid search cross validation. So basically cross validation is a technique which is used for hyperparameter tuning. So hyperparameters are basically the parameters that are set during the before training our machine learning model in order to achieve optimal performance. So cross validation basically choose the best hyperparameters for the machine learning model in order to achieve those optimal performance. And now in support vector machine there are two hyperparameters, that are C and gamma. So C basically helps to avoid overfitting of the machine learning model. So overfitting is a situation in which the machine learning model performs very highly during the training of the machine learning model on the training data, but performs very poorly on the unseen data. So in order to avoid this, we use the parameter C, and the gamma hyperparameter is used to control the influence of each data point in a dataset on the machine learning model. So this set of the value is ideal for gamma and C hyperparameter. So we have created a parameter grid with the hyperparameter as key and the list of values as the value for the key. And then we are going to perform the cross validation by grid search CV and passing in the machine learning model, that is support vector classifier, and the hyperparameters, that is the parameter grid. So now after that we are going to train our model by grid.fit scaled x train and y train, that is the scaled features for training and label for training. So now our model is going to be trained. It will take some time, and till then this was all about the support vector machine that you need to know in order to build this a machine learning model for predicting quality of wine. But if you want to know more about support vector machine, I will add a reference to the book Introduction to Statistical Learning in the description box, and you can go to the section 9 here. So the section 9 basically talks about the support vector machine. So if you want to know more about support vector machine and the maths behind the support vector machine algorithm, you can reference this book. And now we are going to wait for some time till our model gets trained. So now our model has been trained now. So in the next line of code, what we are going to do is check for the best parameters. So we are going to use .best params functionality in order to find the best parameters during the cross validation. So during the cross validation, the grid search basically selects the best parameters from these set of values for the hyperparameters C and gamma. So here in cross validation, the value for C is selected as 1, and for gamma the value is also selected as 1 in order to perform optimal performance of the machine learning model support vector classifier. So our machine learning model has been trained successfully, so we can move to the next step. So the step 5 is testing the machine learning model. So for that we have to import the evaluation matrix, that are confusion matrix and classification report from sklearn.matrix. And after that we are going to perform the predictions, that are grid predictions equal to grid.predict scaled testing data, and we are going to perform the predictions. And after that we are going to print the confusion matrix, and the parameters are label for testing and the predictions that are performed with the machine learning model. So now we can see the confusion matrix here. So we have predicted 619 legit wines correctly and only 4 fraudulent wines correctly. Now we can see the classification report also, and we can see for the legit wines the precision is 96% and the recall is 99%, and for which is pretty good. And for fraudulent wine the recall is 15% and the precision is 50%, that is pretty low. So we have kept this machine learning model as simple as possible in order to make it more open-ended for you guys. So it's your task to manipulate the code in order to improve the performance of the machine learning model. So you can do it by balancing the dataset while pre-processing the data using smooth technique or other techniques, and by selecting different machine learning classification algorithms during the model selection. So I hope you get to know how to build a machine learning model for wine quality prediction. So this source code will be provided to you guys in the description box. Thanks for watching the video. I hope to see you again.